Hello again. Thanks for watching this video and for studying your math at COD. Today's topics are important and are shown here, but they are, again, largely a review from prerequisite coursework. Remember to read your book. Those examples are different than the ones I'm going over, and to pause and play the video to test your understanding as we do guided study note examples. Last, not least, get help from at least one of the many support options available if you need it. The point-slope form of a line is applicable when we have a point, in this case x1, y1, and a slope m given. Then the equation of this line is y, the variable, minus the y-coordinate of the point given, is equal to m, the slope, times x, the variable, minus the x-coordinate of the point given. These parentheses are important. You'll get the wrong answer if you don't do that. So here is a guided study note example from your handout. Pause the video, read the problem, do the problem, and then hit play to check your answers. Pause the video now. Let's see how you did. I would have accepted any of these answers since I was only asking for an equation of the line. Here's another example from your guided study note handout. Pause the video, read the problem, do the problem, then hit play to check your answers. Pause the video now. Let's see how you did. And the answer, we wanted this in the standard form ax plus by equals c, so it should look like this. We also speak of the slope-intercept form, which is useful when we know the slope and the coordinates of the y-intercept. We've solved for y as of the form y equals mx plus b. So if you solve for the y, the coefficient of the x is the slope, and the term without the x tells you the y-coordinate of the y-intercept. If you cannot solve for y, the line cannot be put into the slope-intercept form. So here is another guided study note example from your handout. Pause the video, read the problem, do the problem, and then hit play to check your answers. Pause the video now. Let's see how you did. The slope should have been positive 3/4, and the y-intercept is 0 and negative 3. Another example from your study notes handout. Pause the video, read the problem, do the problem, then hit play to check your answers. Pause the video now. Let's see how you did. The directions ask you to find the equation of the line in slope-intercept form, so that is what we did here, and we used that to graph the line on the XY plane. Another guided study note example from your handout. Pause the video, read the problem, do the problem, then hit play to check your answers. Pause the video now. Let's see how you did. We also will talk about vertical and horizontal lines. An equation of a vertical line that passes through the point AB is x is equal to a. It is a vertical line. An equation of a horizontal line passing through the point AB is y equal b. It is a horizontal line. The slope of a vertical line is undefined. The slope of a horizontal line is 0. Parallel lines have the same slope. Perpendicular lines, neither of which is vertical, are perpendicular if and only if their slopes have a product of -1. Thus, the slopes of perpendicular lines, neither of which is vertical, are negative reciprocals of each other. Because a vertical line has an undefined slope, it does not follow the mathematical rules for parallel and perpendicular lines. But we intuitively know that all vertical lines are parallel, and that a vertical line and a horizontal line are indeed perpendicular. So here are some problems from your guided study notes. Please pause the video, read the problem, do the problem, and then hit play to check your answers. Pause the video now. Let's see how you did. Here are the answers. Parallel lines will have the same slope, so we find the slope, and then we use the point slope form and put the equation in a form that is usable. Here, the perpendicular line is going to be the negative reciprocal slope, not the same slope. And we again use the point slope form and write it in this form. This is a nice summary, it is in your book, of all the forms: the slope-intercept form, the point slope form, the standard form, and the forms for horizontal and vertical lines. We can also write equations of lines that mathematically describe or model real data if the data change at fairly constant rate. In this case, we assume the data fit a linear pattern and the rate of change is the slope. So here is a problem from your guided study notes, and what you should do is pause the video, read the problem, work the problem, and then press play again, and we'll see how you did. Let's see how you did here. These are the answers you should have gotten. The last example in this section talks of solving an equation using a graphing calculator. Now, it turns out that you don't really need a graphing calculator to do this, so let's do this using principles that we know of. So please read the problem, pause the video, do the problem, and then start the play to see how you did. Let's see how you did. So what I did is I considered graphing y equal this side and y equal that side, which is what you would do on your calculator as well. These are the two equations simplified that we have, and if we graph them, we see they intersect at x equal minus 4, comma 30, and that means x equal minus 4 really is the answer because they just ask us to solve this for x. Truth may, time and interest permitting, give some additional coaching about the calculators for earnest students seeking more learning, but I will not assess you in class on graphing calculator skills. In closing, time is precious, each day must count. Do the math, it will make you strong.